Assalamu alaikum everyone. Welcome back to Easy Talim. Suppose Cambridge gives you this. It gives you three coordinates A, B, and C, and it asks you to find the equation of the circle. Now, most students are going to panic here because they think they have entered a completely different topic. However, you haven't. Today, I'm going to show you something surprising. Circles are not a new chapter, they are simply coordinate geometry wearing a different outfit. Everything you've learned, midpoint, gradient, perpendicular gradients, distance, completing the square form, right? Quadratics all come back today, and by the end of this lecture, you'll realize Cambridge isn't testing circles, it's testing relationships. How can a computer draw this? How does Google Maps know where a circle is? How does CAD software know about it? There must be an equation. So today's goal is not to memorize, but to build it. Previously, coordinate geometry taught us the distance for two given points. It taught us the midpoint between the 2 points. It taught us the gradient between the 2 points, y2 minus y1 upon x2 minus x1. That was rise over run or change in y over change in x. It also taught us the perpendicular bisectors and the perpendicular gradients for two lines, let's say AB and BC, which are perpendicular to each other. Then the product of their gradients always is equal to -1. And we also did quadratics previously in functions as part of functions, and that in order to find the roots we have to put how we used to derive the formula, the quadratic formula. And also we did the completed square forms, a times x minus h whole square plus k, that produced us the vertex at h minus h comma k. And if a was greater than 0, this was minimum, and if a was less than 0, this was a maximum type curve. Plus, we also did the discriminants, which showed us or which identified to us how the curve behaves, whether it has. So, if the discriminant is greater than 0, then the curve either intersects like this at 2 points or like this at 2 points. If it is equal to 0, then it is only tangential, and if it is less than 0, then the curve either lies totally above the horizontal axis or totally below the horizontal axis. So today every one of those returns. This is why in the last chapter or in the last lesson on Tuesday, coordinate geometry wasn't finished. It was preparing you. Now, from your O level or GCSE math geometry, you already know what a circle is, that it is a locus of points which is equidistant from a particular point, which is called the center of a circle. And from coordinate geometry, we have already learned distances, and if you have seen our previous lectures, you have done both these topics in quite some detail, right? Now, let's say that you have a circle, right? The center of which is at point AB. Now we are deriving the equation of a circle. Let's say this is A comma B, so this has got to be A and this has got to be B. Now let's say that there is a random point XY on the circle. This point could be here or here or here. We are assuming it to be right here, where I am highlighting it for you guys to look at it, right? Now, okay, it is recording. Now, we also understand that the distance between any point on the circumference and the center is called the radius, right? Now, if I drop a perpendicular line from this random point to the horizontal axis, and from the center to the horizontal axis, and if I also draw two horizontal lines from these two axes, between these two coordinates and the y-axis, then you will be able to identify a right angled triangle here, right? I hope you are already able to see that. So there we have a right angle triangle. So if the 90 degrees angle is right here, then the side opposite to it is called the hypotenuse. And whenever this hypotenuse is involved, then we always know that more often than not, we are talking about the Pythagoras theorem, and here we are going to do exactly the same. Now, if I am going to ask you what is this distance going to be, if this point is y and this point is b, then you will tell me that this distance is going to be y minus b. Now, it may be confusing you, but let's say that if this is y, let's say y is 8 and b is 5, then you will tell me that of course this distance is 3. Why is it 3? Because 8 minus 5, right? So this is exactly what we have done here. So the perpendicular distance is going to be y minus b, and the horizontal distance between them is going to be x minus a, right? Now what we can do is we can simply put them all together in a Pythagoras formula, which is base squared plus perpendicular square is equal to hypotenuse square, right? Now hypotenuse is radius, so we are going to say r square. Base is x minus a whole square, and perpendicular is y minus b, and because it is perpendicular square, we are going to put a square here as well. And here you have your equation of a circle, right? So radius square is equal to x minus a whole square plus y minus b whole square, and that's it, right? This is not magic. It's only the distance formula, and by the way, this is exactly how you calculate distance between any 2 points, and this is what I showed to you in my last lesson as well. Now, having said that, it should already make it easier for you or identifiable for you to read an equation of a circle. So for example, if you're given x minus 3, if you're given an equation x minus 3 whole square plus y plus 5 whole square is equal to 16. Now, first of all, I could see that both of them, both the terms here were a difference, right? So a minus sign has to exist between them, because here we take difference of 2 points, right, in order to calculate the horizontal and vertical distances, right? So first of all, I need to convert this equation, the orange equation, into a similar form, right? So I have to convert this in this form. So this is going to become, so x minus 3 is okay. So x minus 3 whole square is fine. So a is equal to 3, and plus y plus 5 has to be converted into y minus 5, okay, such that my b becomes minus 5, and 16 may be rewritten as 4 squared, which is going to give me my radius as 4. So what does this show us? This shows us that our a and b, which is now 3 comma negative 5, is our center of a circle, and the radius is 4. So if you wish to plot it, it's quite easy. You can simply do it like this. So if this is 3, then this is 5, this is negative 5, and the radius is 4. So the highest point is going to be at negative 1. The rightmost point is going to be at 7. The leftmost point is going to be at negative 1 right here, and the bottommost point is going to be at negative 9. And then you can draw a circle around it, right? As easy as that. Of course, since I don't have a space here, I will not be able to do a very good job, but just to give you an idea of how you can really draw these circles, right? So this is how you do it. Now, so you should never be confused about if your y plus 5 right here got converted into y minus 5, because we have to take the difference of minus 5 with y and square it in order to apply the Pythagoras theorem, right? And I gave you the complete derivation a minute ago, right? Just like we used, so inside works opposite, just like the function transformation that we did earlier, that if you had x plus a, function of x plus a, then this is a horizontal translation of negative a and 0. The translation vector is negative a0, right? So this is the first callback. Now, so a general form is going to be what? Let's apply the quadratic formula here. So let's say instead of this completed square form that you're given right here, you're given a form which is something like x square plus y square. I'm giving you a very generic or an easier one to deal with. Plus 6x minus 8y minus 40 is equal to 0, and you have to prove that this is the equation of a circle. So first of all, let's collect the like terms. So x square plus 6x, let's put those together, right, and put a bracket around it. Then let's collect y square minus 8y, so this becomes plus y square minus 8y, and I put a bracket here as well, and let's move the constant to the other side, right? So is equal to 0. However, now you cannot argue here, and I will explain to you why that under root 40 is going to be the radius, because it's not calculated as yet. Okay, so let's not jump to conclusions right away. Now, let's, because in equation of a circle we do not have x squared here inside the bracket, right? So let's put it in a completed square form. So now x squared plus 6x may be converted into x plus 3 whole square minus 3 squared. Okay, and this y squared minus 8y may be converted into y minus 4 whole square minus 4 whole square. And I really pray that you guys remember from our last lectures on quadratics that how do we do this completed square form. If not, go on the channel on this very playlist of AS Math October November 26 and watch both the lectures on quadratics, right, for a very quick revision. Now this becomes x plus 3, or I would rather write it as x minus 3 whole square minus 9, and this becomes plus y minus 4 whole square minus 16, and this is equal to 40. So minus 9 minus 16 is what? It is negative 25. Add 25 to both the sides. So what do you get? So I add 25 here and I add 25 here. So now my final equation is going to be x minus 3 whole square plus y minus 4 whole square is equal to 65. Now I can see that my radius is square root of 65. My center of this circle is negative 3 comma 4. So this is the center of a circle. So we applied the already learned concept of completed square form in order to derive the in order to use the given equation to find the center and radius of the circle. Okay, now let us do another example and try to see whether this forms a circle. Now, let's say, so first of all, we have to get rid of these coefficients of x square and y square, because we ought to have one coefficient in order to form the equation of a circle. Otherwise, the shape either becomes an ellipse or something else in solid geometry. But that's not part of your syllabus. You do those in further math. Now, if I take 2 common, I get x squared plus 7 upon 2y, or let me also collect the like terms together. So this becomes x squared minus 5 upon 2x plus y squared plus 7 upon 2y, and I can divide by 2 on both the sides. So this is what I get, right? So this is what I have right now. Now let's see. So this becomes x minus 5 upon 4 whole square minus 25 upon 16. I completed this square, and this one becomes y plus 7 upon 4 whole square. So my b is going to be negative 7 upon 4 and minus 49 upon 16, and this is equal to 1/2. Okay, now this becomes what? So this now right here is x minus 5 upon 4 whole square plus y plus 7 upon 4 whole square is equal to half plus 49 plus 25 is 64 upon 16. No, 75. Yeah, 74 upon 16 is 37 upon 8. Okay, so plus 37 upon 8. So I can convert this into that as well. So this becomes 4 upon 8. So this is 41 upon 8, right? So let me write this down here. So 41 upon 8. So my radius is going to be under root of 41 upon 8, and my center is going to be at 5 upon 4 comma negative 7 upon 4, because I ought to rewrite this as y minus 7 upon 4. This is not a good practice to display the answer like this. I mean, do not display the answer like this, but of course it's better than taking your b or the y coordinate of the center as positive 7 upon 4, right? So it is definitely negative 7 upon 4, okay? Now, for any given circle, let's say this is x, let's say we use this above example only, x minus 5 upon 4 whole square plus y plus 7 upon 4 whole square is equal to 41 upon 8. Now, if we increase this constant here, you should know that your this is going to expand your circle or increase the size of your circle, right? Now, if we move this, our center is going to move left or right. If we move this part, our center is going to move up or down, right? So this is how you do the transformations in circle. Now, one very funny variation that students find and unfortunately lose marks on as well is that sometimes the examiner in Cambridge is going to ask you that A, let's say, is 1 comma 5, B, let's say, is minus 8 comma 16 are the endpoints of a diameter. Find the equation of a circle. Now this is extremely easy. Why? Because see, if A and B are the endpoints of a diameter, so we can draw. So first of all, you should be able to visualize it, okay? Because half the math is solved when you understand what is happening. Now, if it is the endpoint of a diameter, so A and B hypothetically should be here, okay? Or I can now, because this is minus 8 comma 16, I can draw it like this, okay? So this point right here is B, which is minus 8 comma 16, and this point right here is 1 comma A, which is 1 comma 5. Now, if this is the diameter of a circle, then the center must exist somewhere right here, right? So the midpoint of AB is the center. Now, we learned in our earlier lessons that the midpoint is nothing but the averages of the coordinates. So this is going to be minus 7 upon 2 comma 16 plus 5 upon 2 is 21 upon 2, right? So the center is right here, and the distance is going to be what? The distance is going to be half of the distance AB, right? So just find the distance AB, which is going to be 16 minus 5 is 11, so 121 plus this is 9, so this is 81, so whatever that is, so this is under root 202. So under root 202 divided by 2 is going to be the radius of this circle. So you can form the equation right away, and this is going to become x minus this, so x minus 7 upon 2, so x plus 7 upon 2 whole square plus y minus 21 upon 2 whole square is equal to this square. So this becomes 202 upon 4, which is 101 upon 2. So that is going to be the equation of a circle using just 2 points if they are the endpoints of a diameter. Now, chord comes quite often with circles, like you used to do in circle theorems in your O levels or GCSE as well. Now, if I ask you that can any radius bisect a chord, let's say if I take this radius, right? So will this be able to bisect the chord into 2 equal halves? Your answer must be a no, because only the perpendicular ones do this job, right? So we have learned this in our O levels GCSE circle theorems as well, that if I drop a perpendicular from the center to any point on the chord, it bisects the chord, right? Because if this is 90 degrees, then because this is radius and this is radius, therefore these two angles ought to be equal. Let's say that this is theta and this is theta, and if this is 90, this is 90, therefore this is going to be 90 minus theta, and this is going to be 90 minus theta as well. So now we have so now we have two identical triangles, right? So if this is radius, and this is the common line or the common perpendicular between these two triangles, so this is also equal in both. Therefore, by side angle side property of identical triangles or congruent triangles, this side ought to be equal as well. So this is going to get split into 2 equal halves, right? Now we also did one more property. Allow me to clear this up. Because I will be using the same circle to explain you another property. In case you need it, you can go back and take a screenshot. Now, if I draw a tangent to this circle, the And if I drop a radius from the center of this circle onto the point where this tangent is touching the circle, then it only does at 90 degrees, right? So this is always going to be a 90 degrees angle, right? So this is the tangent property, and this is most examined because a lot of times the examiner is going to give you a point outside the circle and is going to say that there are two tangents originating from this point to the circle, and there are going to be only two of them, right? There can't be a third one because the third one is going to intersect or not be a tangent, right? So now when they ask you, then you right away form a diamond shape, and there are quite a few properties of a diamond shape as well, and we are going to cover those right away. Now, first of all, if we drop the perpendicular from the center of the circle to the points where these tangents are touching the circle, this is always at 90 degrees. So this is 90 degrees, and if I join these 2 points, the center of the circle and the point of the points these tangents are originating from outside the circle, they are going to form the diagonal between a diamond. Now these two sides are same, right? Because they are both radius, we know it. This is 90 degrees, this is 90 degrees. This blue line is the side common to both the congruent triangles. Therefore these tangents are ought to be of equal length. So if this is B, then this is also going to be B. Now we can see that we have got two congruent triangles. One is right here, right, and the other is right here, right? They're congruent, identical triangles. The sides, the angles, everything is equal. Therefore we can see that if this angle is alpha, then this angle is alpha. If this angle is beta, then this angle is also beta, right? And there's another property for diamond, and diamond shape is always like this, right? There are two sets of equal lines. It's difficult to draw, so two sets of equal lines, right? And their diagonals, they intersect at 90 degrees. Right now this is not the perfect diamond that I formed here, so don't. Okay, maybe this is the perfect diamond, I don't know, but yeah, their diagonals intersect at 90 degrees. Okay, so if I drop a line between the 2 points of tangencies, then these two angles are going to be 90 degrees as well. Okay, so this is the property for two tangents from an external point, that both tangents are going to be of equal length from the point of origin of the tangency and to the point T1 and T2. Okay, and if this is, let's say, M. Now we began our lecture from this. Okay, let me go there. So we began our lecture from right here, that if you had 3 points A, B, and C, then how do you find the equation of a circle? Now that's pretty easy. We did it in towards the end of our last lecture on coordinate geometry 2 as well, that if you draw, so this point is C, so if you draw a perpendicular bisector between B and C, right? So how do you draw a perpendicular bisector? You find the midpoint of B and C, and then you take the negative reciprocal of the gradient of B and C in order to find the gradient of the perpendicular bisector, and then you draw a line through the midpoint which is perpendicular to this, right? And this is so this is going to be one line. So I will remove all the rest. Now then what you can do is you can then find the perpendicular bisector of AB through the same formula. Oh, wait a second. Now now this also does the same thing. You find the midpoint, do the negative reciprocal, and draw a line through, draw a perpendicular bisector of AB. Let me remove this now in order to create. Now the point at which these two perpendicular bisectors, they intersect, that is the point which is equidistant from B, which is equidistant from C, and which is equidistant from A. Why? Because you formed the perpendicular bisector of BC. This one is the perpendicular bisector of BC. So every point on the pink line is going to be equidistant from B and C. So all of these highlighted points here are equidistant from B and C, right? Now all the points on this green one are also going to be equidistant from A and B. However, there is only one point which is equidistant from, so this point right here is equidistant from B and A. And if this point is equidistant from B and A, then whatever point is equidistant from B on the line, on this pink line, is also equidistant from C. And hence, this particular point is equidistant from here and from here and from here. Therefore, this is going to be the center of a circle on which on whose circumference lies all these 3 points. Okay, so that's about it. And if I would rather that we do one question on it as well. So let's do, and without geometrically. Okay, so let's say that we have A, which is 1 comma 5. I don't know why I always take this. B, which is 7 comma 7 comma 10, and C, which is -3 comma -7. Okay, now let's see. So if I draw a perpendicular bisector between AB, so that's going to be, so first of all I find the negative reciprocal, so the gradient between them is what? So it is 10 minus 5 over 7 minus 1, which is 6, so 5 upon 6. So the perpendicular bisector is going to be minus 6 upon 5 first of all, so that's the gradient of that. And the midpoint of A and B is nothing but 4 comma 15 upon 2, right? So the equation of this perpendicular bisector is going to be y minus y1 is equal to m times x minus x1. So this is the equation of the perpendicular bisector between A and B. Now let's find the equation of a perpendicular bisector between B and C. Okay, now let's do that. So the midpoint of this is 7 minus 3 is 4. So this is 2 comma 10 minus 7, 3 upon 2. So this is the midpoint of B and C, right? And the gradient between these 2 points is 10 minus 17 and 10, so 17 upon 10. So this is going to be minus 10 upon 17, right? So this is going to become y minus y1 equals to m x minus x1. Okay, now you have got two equations, and solving them simultaneously you are going to find the equation of the solution at which the point of intersection at which these two perpendicular bisectors intersect, which is going to be the center of the circle. Now this becomes, so y minus y, so this is 15 upon 2, I'm doing this equation making y the subject, minus 6 upon 5 x minus 4, and if I make y the subject here, this is going to become 3 upon 2 minus 10 upon 17 x minus 2. So this becomes, okay, so this is 12 upon 2, so this is 6, and this becomes 6 upon 5 x minus 4 minus 10 upon 17 x minus 2, and we can take the LCM. So 17 times 6 is 102 times x minus 4 minus 50 times x minus 2 is equal to 85 times 6. You can do the math yourself as well. So this becomes 102x minus 408 minus 50x plus 100 is equal to 175, 110. So this becomes 52x, and this becomes negative 308. So 818 is equal to 818. Now you can do the rest of it. I mean, so this is 212 over 13 is equal to x. So this is how you find the x coordinate of the center, and then using it in either of the perpendicular bisectors, whether you use it here or you use it here, you find the y coordinate of the center of this circle, and then once you have the center of the circle, right, now use this center of the circle, and so this center of the circle, this radius is probably lying is, so this is A, this is B, this is the center of the circle. Now you have this coordinate, and they also told you, sorry, this was point A on the circle and this was point B on the circle, right? So now you can use the distance between this particular point, x coordinate of which is 212 comma 13, the center and the A. So this is going to give you the distance which is going to be the radius of it, right? So it is as easy as that. So I will just quickly recap, because this question is the climax of this chapter. Okay, so there are 3 points, no center. So how did we find center? We found the perpendicular bisectors between two sets of points, and then we solved it simultaneously in order to find the center of the circle or their point of intersection. So that's the circle, and everything in this question, it came from coordinate geometry, and coordinate geometry not of A levels, rather of O level math, right? And this is how we can derive the equation as well. So this probably, I would say, is the wow moment of this lecture. Now I will be doing quite a few examples for circle and line intersections, and after that we will be doing the examiner advice as well. Okay, now we will do an examiner style question. Now let's say that a line is given, the line y is equal to 2x, 2y minus x is equal to 12, and an equation of a circle x square plus y square minus 10x minus 12y plus 36 equal to 0, right? Now let's say that they've given to you that this line intersects this circle at 2 points A comma B. So the first question is to find the coordinates of point A and B. Now that's fairly simple. You just substitute this line into this function. So this becomes what? So let me make x the subject. So this becomes 2y minus 12. Now let me put this right here. So this becomes 2y minus 12, and the mistake that students make is that they don't put it right here as well, right? So make sure that you don't make that mistake. Now plus y square minus 10 times again 2y minus 12 from the equation of a line right here, and then plus 30 minus 12y plus 36 equal to 0. This is a quadratic, so must give us two solutions. So which is going to be the y coordinates of A and B both, right? So we are right now finding this and this. So this becomes 4y square minus 48y plus 144 plus y square, so I'll make this 5y square, and this is negative 20y, so I will make this negative 68y, and this is plus 120, so I will convert this into 264, and then there's a negative 12y, so I will put this as minus 80y, and then there's a plus 36 is equal to this. So now this becomes 5y squared minus 80y, and this is plus 300 equals to 0. I can factor the 5 out, so this becomes y squared minus 16y plus 60 equals to this. So 10 times 6, so y squared minus 10y minus 6y, or minus 6y minus 10y plus 60 equal to 0. So y minus 6 minus 10y minus 6. So my one coordinate, y coordinate, is 10 and the other is 6. So I will put 10 here and 6 here, and then since this is a point of intersection between line and the circle, so I can put this in the line as well in order to get, or put it right here. So this becomes 20 minus 12 is 8, and 12 minus 12 is 0. So A will be 8 comma 10, 8 A or B, it could be either, we don't know for sure. So and B is 0 comma 6. The second question is going to find the equation of the perpendicular bisector of AB. Now if you have to find the equation of the perpendicular bisector of AB, which is, so the midpoint is what? The midpoint is going to be between let me change color. So midpoint of AB is going to be the averages of x and y coordinates, so 4 comma 8. So this is the midpoint, and the gradient between A and B is 10 minus 6 is 4, 8 minus 0 is, so if this is half, so the perpendicular gradient is going to be negative 2, right? So the equation of a line is going to be y minus y1 is equal to mx minus x1, or y is equal to negative 2x plus 8 plus 8 is plus 16. So this is going to be the equation of the perpendicular bisector of AB. Now it's part C may ask you that the perpendicular bisector of AB intersects the circle at points P and Q. Now, so the perpendicular, so we now solve this with the circle, because this is a separate line, right? So now if you put minus 2x plus 16 into this circle equation, and let us do it. So this is x squared plus y squared. X squared plus y squared. Y squared is 16 minus 2x squared, and minus 10x minus 12y minus 10x minus 12y, which is 16 minus 2x, and then plus 36. And plus 36 equal to 0. And the solutions that we are going to get are going to be the coordinates of P and Q, because this line intersects the circle at P and at Q. So this becomes, so 4x squared plus x squared is 5x squared, and this is plus 256 minus 64x and minus 10x. So this becomes minus 74x. And this is 192, negative 192. So 56 and 8 is 64. So I will just write 64 here. I've dealt with this as well. And negative 12 times negative 2x is plus 24x. So plus 24x. So this becomes negative 50x. And plus 36 equal to 0. So this becomes 5x squared minus 50x plus 100 equal to 0. So this is x squared, factoring 5 out, minus 10x plus 20. So this is okay. So we will apply the quadratic formula here because we can't do it otherwise. So this becomes x equal to minus b plus minus under root b squared minus 4ac upon 2a. So this is 10 plus and minus 2 root 5, because 20 can be written as 2 root 5 over 2. So this can be written as 5 plus and minus root 5. So one x coordinate, so P is 5 plus root 5, Q is going to be 5 minus root 5, and now put these coordinates in the equation of a line which is right here, y equals to minus 2x plus 16, and you will get the y coordinate of P and Q, right? So that's it. And then they can, so once you have P, once you have Q, you already found out A and you already found out B, then they may ask, now all these four lie on the, so this is A, this is B, I don't know, this may be P, this is Q. Now they may ask you to find the area of this quadrilateral as well, right? Which is quite fine. You can use the shoelace formula, and we will come to that in a bit, not in this lecture but later. Shoelace formula. So if A is x1 y1, B is x2 y2, C is x3 y3, D is x4 y4, then you put this first one again, which is A, which is x1 y1, put the modulus sign, put a half here, and this gives you the area. So now you multiply x1 with y2, so this is x1 y2, you multiply x2 with y3 plus x2 y3, you multiply x3 with y5 plus x3 y5, multiply x4 with y1 plus x4 y1. So this is this. Then you subtract the sum of the products of these. So this is x2 y1, this is x3 y2 plus x3 y2 plus x4 y3 and plus x1 y5, whatever the answer is, whether negative, positive, you take the absolute value, the positive of it, half it, and this gives you the area of this quadrilateral, and this is probably 12 marks in your P1 paper, right? So now one advice that I'm going to give you, which we read most of the times in the examiner reports, is that students often lose marks because they solve before identifying. Also, in this very chapter, you also will be asked to given the unknowns, you will be asked to use the discriminant Let's say that they are going to give you that there is a line y equals to 8x minus k, which is intersecting the curve x square plus 5x or plus 8x plus y square minus 7x is equal to 101. This is intersecting. Find the values of k for which this line intersects this circle at 2 points. If it intersects at 2 points, then the discriminant between line and circle is going to be greater than 0. If this intersects at 1 point, which means that this is tangential, then the discriminant is going to be equal to 0. If it does not, then we will say, so if no intersection, then we will say that the discriminant is going to be less than 0, right? So this is how. So here you are going to get range of values of k, here you are going to get range of values of k, and here you are going to get just one value of k. Okay, now, so we were talking about the advice as per the examiner reports that we come across. Students usually lose marks because they solve before identifying, right? So always ask yourself, what relationship is Cambridge testing, not what formula do I know, distance, midpoint, perpendicular, bisector, equation of a line, blah blah blah, point gradient formula. Don't do that. So for example, if diameter is given, that then you have to find the midpoint in order to get the center of a circle, right? If you're given the endpoints of a diameter, right? If you're given 3 points, then you have to find the two, using the two sets of points, you have to find the perpendicular bisectors and then solve them simultaneously. If you're given the tangent, then you have to use perpendicular gradient, because the so if this is a point, let's say AB, and this is a point, and this is a point, let's say XY, and this is a point PQ, then definitely, let's say this is point X, this is point P, and this is point C, then CP is definitely perpendicular to PX, right? We already found out that the radius always intersects the tangent at 90 degrees. So this gradient between CP, so of CP, product of with PX, is definitely going to produce a -1, right? And how to find the general equation, how to do the completing square form, and if line intersects the circle, it produces a quadratic, then you have to use discriminant if there are if there is an unknown and they have given you a hint through whether it intersects at 2 points or a single point or doesn't intersect at all. So today we learned the geometry. Next lecture, we are going to begin with circular measure, where suddenly radius, circumference, arc length, sector area. So now in circular measure, in the next chapter, we are going to do these shapes, which are the sectors, right? Which you have done, but we are going to introduce a new metric through which we calculate the angle, which is going to be known as radians, where we do that pi radians is same as 180 degrees, and we are going to derive a lot of very neat formulas for arc length, for the sector area, and all of this become one elegant system. Interestingly, without today's understanding of circles, this next chapter, which is circular measure, this is the fourth topic out of 11 in your AS syllabus. It feels without today's lecture, it would feel like memorizing formulas only. So with today's understanding, the next chapter becomes obvious. Now, if this lecture changed the way you think about circles, don't stop here. Attempt the challenge questions that I will be posting in the stories as well later on my Instagram channel, where we go by the name of Easy Talim, EASYTALEEM. And you can also reach out to me for question bank on my WhatsApp, which is +92 329 3028 485. This is my WhatsApp. If you want structured preparation for your October, November 26 or May, June 27 preparation, our live classes are now open. I'll see you in the next lecture, where we'll begin one of the most beautiful chapters in the entire Cambridge syllabus, which is circular measure. See you then.